In this video, you will learn some of the basics when considering algorithms for big data. One of the most frequently used approaches to finding out information from big data is through data mining. But what is data mining? Most probably you have some ideas on what data mining is about. Think about it for a second. I want to make your notion of data mining precise by providing you the following definition. Data mining is the discovery of models for data. A model can be various things, and I would like to show you some examples. An important example is PageRank by Google, which is used for web search. It models the importance of web pages in the internet. Pages are connected through links in a web graph. In this model, each page is assigned a value that summarizes the importance of that page. I will get to this in greater detail later in the course, but essentially, the number assigned to a specific web page is the probability that a random surfer on the web graph is at this page at any given point in time. A high value means that the web page is an important one. In this example, you can see a graph with 5 nodes and the page rank assigned to every page. It can be observed that the central node, which has many incoming links, gets a higher score than the nodes that have not that many pages pointing to them. In this sense, the page rank of a page is high if it is regarded as important by other pages that link to it. Having the importance of web pages modeled in this way, one score per page allows algorithms to judge the importance of pages as part of an internet search engine. As another example of data model, I'd like to look at the performance of algorithms. Let's say you have designed an algorithm and have run it on various benchmarks. To make things simple, assume that all benchmark instances have the same size, let's say graphs of 10,000 nodes. The runtime of your algorithm on one particular benchmark instance would be measured in milliseconds. Running your algorithm on each benchmark instance gives you a set of numbers characterizing the runtime behavior. If you have done many runs of your algorithm, you might want to have a more compact model of your runtime data. If you assume that the data comes from a Gaussian distribution, then a model can be given by the average of these numbers together with its standard deviation. This chart shows different Gaussian distributions. All have mean 100. 3 distributions having standard deviation 5, 10 and 15 are shown. You can observe that the distributions have higher concentration around the mean if the standard deviation is small. If your data consists of a lot of data points, let's say a billion, in a particular application, then describing your data by just 2 parameters, average and standard deviation gives a very compact description. Having a compact description of your data is useful because you can easily implement algorithms that exploit the model. You will see this throughout the course. Next, you will be looking at how to make data mining models more precise and discuss different ways of modeling data in detail.